Hi, my name is Mananga Mutombo. I am a senior bioengineering student at the University of Illinois, Chicago. This summer, I participated at the University of Michigan Summer Research Opportunity Program, where I worked at the Immunoengineering Lab supervised by Dr. James Moore. We all certainly witnessed the Ebola outbreak of March 2014, which struck West Africa and eventually had a global impact. This outbreak was the biggest outbreak with more cases and more deaths since the discovery of the first Ebola virus strain in 1976. So, my research this summer focused on subunit vaccination strategy using the trimeric Ebola virus envelope glycoprotein in order to create intrabilayer cross-linked multilamellar vesicles for vaccine against Ebola virus. This is how these protocols are made.
Begin by mixing a 1:1 molar ratio of DOPC and MPB in chloroform, maintaining a total lipid quantity of 1.26 micromoles per batch in a 20 milliliter glass vial. Next, add lipophilic cargo to the lipid solution at the desired concentration, and purge the solution with extra dry nitrogen gas to thoroughly remove the organic solvent. Place the sample under vacuum overnight. The next morning, add 200 microliters of 10 millimolar BTP containing the water-soluble cargo of interest to hydrate the lipid film. Vortex the resulting solution for 10 seconds every 10 minutes for 1 hour at room temperature. Then transfer the contents to a 1.5 milliliter microcentrifuge tube. Next, place the tube in an ice water bath with continuous sonication using the 40% intensity setting on a 125 watt 20 kHz probe tip sonicator. After 5 minutes, add 4 microliters of 150 millimolar DTT to the tube, vortex to mix, and spin down the sample in a microcentrifuge. Then mix 40 microliters of 200 millimolar calcium chloride into the sample, followed by cross-linking of the MPB-containing lipid layers with DTT at 37 degrees Celsius for 1 hour. At the end of the incubation, spin down the solution 3 times. Add 200 microliters of double distilled water during the second and third centrifugations to remove the remaining calcium chloride, unreacted DTT, and unencapsulated cargo materials from the supernatant. After the last spin, resuspend the ICMVs in 100 microliters of freshly prepared peg thiol for 30 minutes at 37 degrees Celsius. Then wash the vesicles 2 more times in double distilled water, resuspending the final pellet in PBS, and store the ICMVs at 4 degrees Celsius. To characterize the particles, mix the cold ICMV suspension before diluting a small aliquot of the sample in a total volume of 1 milliliter of double distilled water. Then place the ICMVs in a zeta sizer cell and use a dynamic light scattering and zeta potential measuring system to measure the particle size, polydispersity index, and zeta potential of the samples according to the manufacturer's instructions.